Okay, good morning, everyone, or afternoon, depending on where you are. This is Anthony Alaka with Torrey Hills Capital, and I want to welcome you to the Ventripoint Diagnostics podcast for April 28th, 2021. I hope everyone is doing well under the circumstances, and I want to thank you all for attending today's virtual presentation. We are very excited to bring you Ventripoint Diagnostics today. The company's recent performance has been nothing short of amazing as they've made some key announcements that have really put the company in a position for continued success. In fact, just yesterday, the company announced a collaboration with GE Health, the $18 billion healthcare business of GE. And we believe their technology is a game changer in the medical imaging space for many reasons, and feel that based on current fundamentals, as you just heard us, George and I talking about, the stock presents an excellent value for investors. Just a brief background, Ventripoint Diagnostics is a commercial stage AI healthcare company that has developed an extremely valuable diagnostics platform, which addresses a very large unmet need in the medical scanning market space. Ventripoint's platform enables the massive in-place fleet of two-dimensional ultrasound devices to create highly detailed and accurate three-dimensional views of the heart. Prior to the introduction of Ventripoint's solution, the only way to get this data was using MRI technology, but the use of that equipment to perform this task had a number of significant drawbacks, which we will cover during this call. These limitations to using MRI to scan the heart have really created a massive market opportunity for Ventripoint to move this platform into the healthcare community in a big way, which will also be addressed during the presentation. Ventripoint Diagnostic trades on the OTC market under the ticker VPTDF and on the TSX Venture Exchange under the ticker symbol VPT. The shares are currently trading at roughly 44 cents US, representing a market cap of roughly $56 million. And, we feel with the pullback yesterday, there's still plenty of upward potential as the company continues to execute its growth strategy. With us to discuss Ventripoint Diagnostics and their growth strategy going forward is the company's Executive Chairman and CEO, Dr. George Adams. George, welcome.
Glad to be here.
I'm glad to have you, and welcome to our virtual lunch, and thanks for taking some time to bring our viewers up to speed on Ventripoint Diagnostics. If our viewers have any questions during the presentation, I think the best way to ask your question is to simply type it into the chat box or the Q&A, and we'll make sure it gets answered. With that said, I'm now going to turn it over to George Adams. George, the floor is yours.
Thank you, Anthony. Well, I hope you're all having a nice lunch wherever you are. So we'll go through this pretty quickly, and then we can get to the questions, because I want to make sure you get whatever information you want to have. So it's been a good year, and since the beginning of the year, we're up 700%. You can see the chart. It's pretty classic, as Anthony and I were talking about just before the call started. It's classic kind of growth chart. We have taken advantage of the increase in the share price periodically to convert all our convertible debt that we had coming into the year. And so we're now debt free, and we have 2 years of cash in the bank. We have some existing warrants at 50 cents, which are starting to be exercised here. When we get up north of 60 cents, people tend to exercise those 50 cents. So we have an additional year's worth of money in the bank now. So we actually have 3 years of money in the bank to run the company at its current rate. But obviously we want to grow the company, and we'll grow it based on revenue. But it's nice to have that cushion for sure. Liquidity on stock is excellent. We've done, we do $1.5 million to $1.5 million a day of stock. Yesterday we did about 9 million Canadian, so that'd be about 6 million US. So that's excellent liquidity, and you can see on the liquidity chart down here that we've had numerous days where we've had those kind of trading. So we are an artificial intelligence company. We licensed a piece of artificial intelligence, global license, exclusive global license from the University of Washington in Seattle. And we have spent the last decade improving that technology and making it better and better. We're now on the third version of the device. We have over 150 publications done over those 10 years showing that the device is equivalent to MRI and very easy. And so we've been improving the usability and user friendliness of the device over the last decade. And we now have a device which seamlessly fits into the way hospitals, imaging clinics work to look at your heart. So using that AI technology, we can give you an accurate analysis of all 4 chambers of your heart. The product is approved in the United States, Canada, Europe, and in China. We've got 16 sites using it currently, and we have 11 more that we want to put in. And obviously COVID, these are mostly hospitals. So COVID has put a real kibosh to our ability to put these things into hospitals. But now that the vaccine is kicking in and hospitals are starting to open up, we've seen much more interest in the marketplace in getting a machine. As Anthony mentioned, we announced yesterday a global alliance with GE Healthcare. They're the #1 provider of cardiac ultrasound equipment worldwide. They have about 42% market share, and they're going to be our marketing partner. So they're going to present our solution to their installed customer base, and we'll talk a bit about that later. We see this as we're only getting started, and there's numerous ways to pass to liquidity and an attractive return on your investment. So when you have a pain in your chest or worse, and you have to go see a cardiologist, the first thing they do is do an echocardiogram on you, a 2D ultrasound, to get a look at how your heart is functioning and whether there's any, and how large it is and how big it is. And they do that in 2 dimensions because that's where you get the best images. 3D, there are such things as 3D ultrasound, but they give you much blurrier images, and not if your heart is any size big at all, then it doesn't give you a full coverage of the heart. So 2D is used worldwide to look at people's hearts. And there's a lot more information in those 2D ultrasounds than are currently being extracted. And the information that's really needed is accurate and reliable volumes of the chambers of the heart. Particularly difficult to get those numbers for the right side of the heart, the right ventricle. And so we'll show you how we go about doing that. The only other way to do it before we came along was do a cardiac MRI. It's very, most places have limited accessibility, and it's very expensive anywhere you do it. And it's not a lot of fun. So you're in there for an hour to 2 hours, you have to be absolutely motionless, and most adults have to be sedated. Most children have to be anesthetized and put on a ventilator. And then, of course, you've been injected with contrast media every time they want to take a picture. So it's very noisy, very claustrophobic. And about 25 or 30% of people don't make it to the end of the first hour, let alone the second hour. So it's very inefficient use of an MRI machine. So we were challenged and have over the last decade managed to get exactly the same information out using 5 minutes of analysis of 2D ultrasound, allowing the patient to move completely during their examination, collecting the images. And that's been a major upgrade between version 2 and version 3. Version 2, we were using a commercially available tracking system. And in version 3, we created our own. We designed and patented and invented our own tracking system, which works much better than any commercially available system. And of course, you don't have to be sedated or any of those things. And then you get the result immediately. First time you go to the cardiologist's office, you don't have to do 3 trips. So it's all about being better, faster, and more efficient. So this is what version 3 looks like. It's just a little mobile stand with a computer. All the magic is in the AI software and in this tracking system. So what we do is we put a crystal on here and a wire that runs into our machine. This is the 2D ultrasound machine here. This happens to be a Philips machine, but our system is agnostic. We can hook it up to anybody: GE, Philips, Siemens, Toshiba, Panasonic, Monterey, SOFT, all sorts of different people. And we have done. So we don't care what kind of machine you have. We just sell you an adapter, which basically turns your 2D ultrasound machine into an MRI. Instead of having to pay $2 to $4 million, it's a $50,000 price tag, or we'll get into the revenue model or the sale model a little later. Excuse me. So this is a reference crystal here. This is a disposable, so you have to have a new one of these each time you do an exam on a patient. So that's an ongoing recurring revenue source for us. So this is what 2D ultrasound looks like through your heart. Because it was invented, it's actually upside down and back and mirror image. So, so top is actually the bottom, and the left is actually the right. But anyway, this is how people got used to viewing them. And if you're an echocardiographer, you would know that these were 3 different views of the same heart. So sometimes they're quite blurry. You can't really see where the different chambers are, like in this one. But we use a sparse data approach to extract all the information possible out of all the different views. So here's how we do that. So a standard cardiac echocardiogram is 16 views taken through 4 acoustic windows. And so we allow the operator, be the sonographer or the cardiologist, to go in there and put on what we call dots and anatomical landmarks. So you go in there and just identify where the wall is and wherever you can be sure it is. So even if you have a really blurry image, you can always have 1 or 2 points where you're sure that's a wall or that's a valve or this is this. We're doing a reconstruction here of a right ventricle because we are uniquely able to do right ventricles. Nobody else can do that. And it's the most difficult one to do. And so we spent, the decade making it so we get the right answer on a right ventricle, which is most people when we started this said was impossible. Even the FDA said it was impossible when we went to them and said we wanted to do it. But we have done it. And so those dots are sent to a database. It does the algorithm. The algorithm comes back with a model. So you can see here, these yellow lines are where the right ventricle is in these views. So you can see some of the views, the right ventricles half in, half out. Some of them it's not even in the view. So what we end up with is a mathematical model of the heart when it's full of blood, and a mathematical model of the heart when it's pumped out as much blood as it's going to pump out, in this case, the mesh versus the solid part. So you can see which parts of the heart is moving, where the blood is, how much is getting pumped out. We offer the addition that you can go in and interrogate the model in combination with the 2D ultrasound. So you can go and look and say, hey, where is the slice in the heart? Where is that view I'm looking at? So this is revolutionary for a sonographer or a cardiologist because they usually have to guess at what view they're looking at, and especially in the United States where the sonographer takes the views and then the cardiologist has to analyze them. But even if the sonographer has a better idea where the view was, the cardiologist there's nothing on there to tell him what he's actually looking at. So that is, and then we can do it for all 4 chambers. I've just chosen here to put this video on doing a left atrium. So again, even though it's at the bottom, it's actually the top. And even though it's on the right side, it's actually the left side. So this is the left atrium down in the bottom right corner there. And you can see that it's kind of lemon shaped and it does a pretty good job modeling that. And it doesn't take, there's very good. And even where there's very little information, even where there's nothing here, the technique, the AI is able to fill in the gaps. And so even you got poor image resolution on a significant part of the heart, you still can do a good job reconstructing it and getting the numbers you need to know how that heart is functioning in that particular patient. So as I said, you get exactly the same information you get from an MRI. We have over 150 publications done by top cardiologists worldwide and certified by the FDA to be absolutely equivalent to MRI. So there's no doubt about that. Huge need, of course. Heart disease is still #1 problem worldwide, even bigger problem in the developing world and other places like China and Russia and Indonesia. They have twice as much heart disease as we do here in North America. Big problem. This $200 billion problem in the United States. That was a 2011 number, so probably twice that now. So it's just a big number. And every year they just spent $1.5 to $2 billion on echocardiography machines, which doesn't give them, which with our system will give them much more information about what's actually going on with the heart. Because we are so good at doing the right side of the heart, the right ventricle, we initially focused in on diseases where the right ventricle is known to be at risk. And so the first one of those is congenital heart disease. So if you're born with a heart problem, it's always the right side of the heart, which is deformed or malfunctioning. If you have a problem with the left side of your heart, you don't get born. So all the pediatric cardiologists of the world are focused in on the right side of the heart. And the guidelines call for those patients to be scanned with echo every 3 months and have the volume of the right ventricle estimated every 3 months, because it's critical that when a heart is under stress, left side, right side, doesn't matter. When it's under stress, it gets bigger. And so the bigger it gets, the more stress it's under. And these congenital heart disease children, as they grow, the heart grows because the child's growing. But if it grows, beyond the natural growth, then it means the heart's under a lot of stress, and you have to go in there and do some surgery and offload the heart. And you don't want to do that too soon, because you'll be doing it every 2 years. But if you leave it too long, the heart is distended, dilated, enlarged too much for too long. It can't come back. It can't remodel, what they call remodel. It doesn't come back to a normal shape when you do the surgery. And then you have an adult person with CHD, which has an chronically enlarged heart, and at a much higher risk for heart failure, right heart failure, and death. So it's a real fine line between going and doing it now or later, and it's all based on volume. So, and you don't want to have to, I think if you ask Anthony, he'll send you the link to the video where Dr. Skinner was talking about his patients, his CHD children, and he was saying that, I don't put them in MRI anymore. I use the VMS because I don't want to traumatize this kid early in the process, because I got to look at, I want this kid to come back every 3 months, and he's going to be my patient until he's 18 years old. So I don't want to traumatize him by putting him in an MRI. So he has built a practice where people come from all over the world almost to his hospital to use our equipment, to be examined using our equipment. So
I will send that link, by the way, to everyone after the call.
Yeah, there you go. So it's a 10-minute watch, and it's, if you want to hear why, someone who really understands how our system works and why it's so useful for them. Dr. Skinner is the guy. So another one we focused in on was pulmonary hypertension. So because the right side of the heart pumps blood over to the left side through the lungs and over to the left side of the heart, anything that happens to your lungs causes back pressure and stresses out the right side of your heart. So pulmonary hypertension is high blood pressure on the right side. That's caused by COPD or lung cancer or asthma or all sorts of lung congestions, backs up, and then again the heart gets bigger. So you can not only diagnose and detect pulmonary hypertension, but you can detect whether the therapies are working or not by simply looking at the size of the heart. And we've seen this a lot now in COVID, right? So that people end up in ICUs on ventilators from COVID, and consequently the right heart gets bigger. And there's now lots of publications out showing there's a direct correlation between the bigger your right heart is, the more likely you are to die. And people actually are using that for triaging people in ICUs, have proposed to do that. I don't know if anybody actually done it, but they're proposed to do it. So 60% of people with in COVID do have a heart problem. And we saw this in SARS 15 years ago. We had about 10% of people were infected with SARS, had acute heart damage. And those same people have gone on to have chronic heart failure now. So here we are 15 years later, and we still have those patients. We're looking after those patients. Hopefully COVID won't be looking like that, but there are a lot of long COVID patients out there with a lot of symptoms of heart disease. The last one we focused in on was the cardiotoxic effects of chemotherapy. So we've been using the same 3 drugs for chemotherapy, lung cancer, breast cancer, for 30 years. And we know 20 to 30% of those people that those drugs will damage the heart sufficiently that those people will go on to have chronic heart disease. And in fact, the American Heart Association crunched all the data in the United States over the last decade and put out a scientific statement saying you're more likely to die from a heart problem after you've been through chemotherapy, and you need to go see your cardiologist every 6 months for the rest of your life and have your heart evaluated and treated when it starts to malfunction, because it likely will start malfunctioning. And again, a lot of that is right heart failure, not left heart failure. So, in every case, Ventripoint's a clinically important tool. We have clinical studies on all of these patients, not COVID yet, but everybody else, showing that this technology can be applied to this patient population. And there's just no way you're going to put people in MRI even once a year. They wouldn't tolerate it, and it's not a good idea. So we took advantage of a lull, probably the wrong thing to do was shutting down between the first wave and the second wave of COVID. But how do we know that we're going to be 3 waves? I guess the infectious disease guys would have told us that's what's going to happen, but we took the opportunity in the fall to put our machines in top hospitals for all these different indications that I've just outlined for you. So the first one was in Erasmus. There's the top cardiovascular hospital in Europe. Patients get referred to them from all over Europe, and they're using it on not only CHD adults and children, but other kinds of heart disease. The second one we put in was in MD Anderson, #1 cancer hospital in the world, has been for the last 30 years. And they're using it, obviously, looking at not only patients as they're being, the therapy's going on, the chemotherapy is going on, but also to follow the patients afterwards to see how much damage was done to their heart and whether that's continuing. Next ones were in Hospital for Sick Children and next door, Peter Monk. So Hospital for Sick Kids does with pediatric CHD and pediatric pulmonary hypertension. And of course, Peter Monk is the largest cardiovascular center in Canada, and it's a world center for adult PH and adult CHD. So happens to be hometown for us, so that works really well. And the last one we put in was in King's College in London. It's the epicenter for COVID, especially UK variant COVID. And so they're obviously looking at trying to figure out what's going on with COVID patients, both acutely and chronic in what they call a long haul people. And in fact, the UK has decided to set up 40 specific centers only to deal with all these long haul COVID patients. There's a lot of concern in the cardiology worldwide that this is like SARS, and they're going to be dealing with these patients for decades, the heart problems caused by COVID for decades. A lot of kind of scary publications out even in the last month or so about asymptomatic people showing up back at the hospital 2-3 months after they initially were positive with major heart problems and going into the hospital and actually dying in the hospital from respiratory and cardiac complications, and they didn't even have symptoms the first time they were infected. So it's an evolving story for sure. So this is my 7th time around. I've done this 6 times before. It's always the same. Get it in the hands of the key opinion leaders, like Dr. Monahan at King's College, runs the annual echocardiography conference in Europe, like Dr. Box at MD Anderson. So get it in hands, get them using it, get them talking to their colleagues, and get the buzz going. So that's where we're at. You'll hear Dr. Skinner talk about it when on that video. He's given us. We published some case studies from him on our website. If you want to see what kind of how he's used it on a few of his patients, there's some detail there. So we have it's a, I guess I'm in the way here. Let me see. So it's there's about 4 million 2D ultrasound machines in the world. And if you just look at the patient population, how many machines you would need to deal with the patient populations that are out there in Canada, US, and Europe for oncology, pulmonary hypertension, and congenital heart disease, you end up with about 40,000 machines would be required to deal with all the scans you would have to do for those patients and a year. And at $50,000 a crack, which is what we sell them for, that would be about $2 billion market opportunity. If you can put COVID in here, it probably doubled these numbers. I think COVID is going to be equivalent to all of these indications put together. How is a small company like us going to sell 40,000 machines? Well, we aren't, because that's what GE Healthcare has come to help us do. They own 42% of the market share. This is what GE's installed base looks like. 160 countries, 4 million imaging machines. They do 2 billion scans a year. So they're everywhere. And they are going to be presenting our technology to all their customer base. And once we get their salespeople trained up and once we get their application specialists trained up, that will not take too long, because it does not take long to learn how to use our system. Current revenue model is we sell it for $50 $50,000 and $5,000 a year maintenance fee, as well as upgrade fee and support. And we have that consumable patch, which we're probably, we're thinking we're selling for $5 a case. So average unit, we do about 1,000 people a year. So we're looking at about $10,000 of recurring revenue on the capital model. We like the leasing model better because the lease model, we get $15,000 up front, and for that, you get the first 200 cases free, and then you get $50 a case thereafter. So that would be a $65,000 a year revenue, a recurring revenue from that model, which obviously we like that one. And that works well in the United States because you don't have to go through a long drawn out budgeting process inside your hospital. And also there is a reimbursement code in the United States where you would get paid anywhere from $100 to $200 to do this procedure, this 5-minute procedure. So you quickly break even on the $15,000 fee in the first 75 to 150 cases, which in most hospitals would be a few weeks, and then after that, you make a profit. If they're getting paid $200 a case, they make 100. We'll make $50,000 off the machine, and they'll make $150,000 off the machine. So this is it works for everybody. We also have opened a companion animal initiative and partnered with the vet school at North Carolina State University. To show that we can do very good analysis on canine hearts, and there are a lot more and more people buying, acquiring animals, adopting animals, whatever, and there's now 100 million companion animals in the United States, and about 10% of those have heart disease. There are 30,000 veterinary practices in the United States. So there's a huge opportunity here. There's no regulatory, we don't have to go through the FDA or anything for animals. So once we get the validation study from North Carolina State, we'll be able to go to assign on a distributor and start offering the equipment to vets. And we're hearing from North Carolina State, the vet school there, that there are numerous vets who want to get into doing this. So as I said, it's my seventh time around. I'm a serial entrepreneur. The stuff I've brought to market in the last 35 years have been used 300 million times to keep people alive or extend their lives. And I was voted the most, entrepreneurial person in the world by the World Economic Forum. I got my picture in Time magazine a few years back for all the different companies that I've created. Desmond Herzon was our CTO, now is our advisor, because he's the one who created the tracking system and helped us get on with going from version 2 to version 3. He's actually stunningly great ultrasound hardware engineer. He's advising us on any changes we make with the hardware, but we're really, most of the forthcoming stuff, the 4D and motion analysis and all those things is all software related, not hardware. And Elvira is our head of everything. She runs our regular group as well as operations. We manufacture these devices in Toronto in our offices. It costs us $5,000 to make them. We sell them for $50, or we release them for $15. A long lead item is 3 weeks on them, so we can quickly make these machines. It takes less than 5 hours to make one, start to finish. So we can easily produce hundreds of these a month in our facility, and we look forward to doing that as GE gets on with life here. And Dave McFedrin is our head of sales. He's had 30 years experience, comes to us from a national sales director of Siemens on selling imaging equipment. So he's currently, and we have one other salesperson currently doing direct calls, but we have other distributors that we've been talking to. So there'll be some announcements forthcoming about other distributors. There are 3 people who own the cardiac ultrasound space. There's a lot. If you're just talking about ultrasound, there's lots of there's 250 companies that make 2D ultrasound equipment, but cardiac is the hardest one. And so there's really just the big companies, GE, Philips, and Siemens have the resources to do all that hardware engineering, then produce these very sophisticated devices, which sell for about $250,000 to $350,000. That picture I showed you of the Philips IE33 machine is a cardiac machine that sells for those kind of prices. So we have a non-exclusive agreement with GE for them to be our marketing partner. We're going to roll that out. We hope to, Philips has about 33% market share. Siemens has about 18. So there's still another 60, 50, 60% of market out there outside of GE's direct customer base that we would like to make aware of our technology. So we'll go forward now and try and partner up with those other two companies as well and roll it out even faster. There are only 3 companies because they buy everybody else. The last major acquisition in the space was Philips bought TomTech back in 2017. It was an analytics company just like us. The natural sort of point where these people would start thinking about acquiring us would be when we had about 80 to 100 top customers using the equipment on a routine basis. And so we've got 16 now, so we got a few to go yet, but we also have GE to help us make that happen. So I think that'll happen a lot faster now. We have talked to other people who are service providers, people who analyze images, mostly MRI and CAT scans and PET scans. There really is no business out there right now where you send out the images, echo, ultrasound images, and have them analyzed. There should be, because about 7% of even 2D ultrasound exams are unreadable. So you do all that work to collect the images, and then they're so blurry you can't read them. With our technique, we have actually been able to show that we can read all echocardiograms, even the unreadable ones. And so we would continue to look for a partner to help, who would be interested in using our technology to provide that service to cardiologists. And so that's a biz dev opportunity that we're currently working on. So $2 billion market, substantially de-risked because we have regulatory, we have key sales to top people, endorsements from top cardiologists, and we're just getting started. And if it hadn't been for COVID, we would probably be closer to our magic 100 users by now. But COVID is starting to lighten up, and people are starting to come back. So I anticipate we'll have a much more sales in the next couple of quarters, and begin to see the adoption rate for this technology, which is solely needed. So that's it. There's lots of other applications I could go through on left side applications like hypertension, high-risk pregnancy, valve replacements, atrial fibrillation. But I'll leave you guys to ask me questions if you want to hear more things we can do with the technology. There, Anthony, over to you.
Yeah, thank you. And thanks for giving us that overview. I want to open it up for questions from our viewers. So we'll wait for a few to come into the queue. But I really want, George, for you to talk about the announcement yesterday, a brief overview of the announcement, and then we have some questions about, that you don't answer in your explanation about that, because that's a milestone announcement, and I think that it really will give our viewers an insight to exactly how it sets the company up for the future. So can you talk a little bit about what happened with this announcement?
Right. So about a year ago, GE decided they were going to go out and invite people to come and be their partners. So they wanted to differentiate themselves from Siemens and Philips. They wanted to bring more capability to their analytics platform across all the cardiac and all the different parts of ultrasound, not just cardiac. But so they came to us and asked us to please attempt to make our software work inside their analytics platform and show them how we could analyze ultrasound exams quickly and efficiently inside their platform. So they gave us the keys to their platform, and we spent 9 months working with that, and finally got the application working inside their platform, everything, and demoed that to them early this year in January, and they were totally amazed that we could do it. We were the only company that had managed to get something to work on that platform in 9 months. And so they said, okay, we'll negotiate a deal. You'll be the first, you're the first guy through the gate here to actually got something work, but we're going to negotiate you. You're going to be our guinea pig to figure out what the deal is going to look like with everybody else that comes later. So we spent the last 3 months negotiating an agreement, and finally came to an agreement, which I had reviewed by a couple of very smart commercial lawyers, and they said it was absolutely equal, fair standard agreement you would expect. And I've heard, I know when I come on, one of my companies was bought by Pfizer. I was in acquisitions in Pfizer. I used to buy companies or attempt to buy companies for Pfizer, and everybody has a dignity level. Everybody, you got to get to be a certain size before you acquire them. And, we used to do this kind of thing. We'd go and say, okay, as Pfizer, we'll put some money in your company. We'll follow you. We'll give you some advice on what you should be doing next. And when you grow up, then we can buy you, because we can't buy you now because you're just not big enough. The due diligence process is too complicated and costs too much for us to be dealing with little companies. We have to get bigger, and then we're happy. And that was true when I ran my artificial heart business. I was amazed when the people from Medtronic said, I don't want to buy you now for 50 million. I'd rather buy you next year for 500 million, because then I know you're a real business. Now you're just a dream. So that's where we're in. So, I've heard from a lot of people saying, a lot of analysts and things who said, getting a deal done with GE is, so many people try and do it, so many people can't do it. So they've been extremely impressed that we've been able to get a deal done with GE. And, one thing, I think it brings credibility to our technology, because I have been answering that question for many years. If your stuff is so good, why doesn't GE or Siemens or Philips want to provide it for their customers? Why don't they license it and put it in their system? And so now, of course, we didn't do it as licensed. We did it more as a distributor agreement, because we wanted them, that's a better deal for us. And that's, it's a non-exclusive deal. So now we can take that deal and to the other players and try and get the same deal with them. So,
that's great.
Anthony, or you want something else?
Yeah. Can you talk about what it was that they sent you a case, right? And
yes.
Yeah. So can you talk a little bit about that and how?
Well, that was a demo we did in January. The state, they said, we got it running and everything. We said it's ready to go. When, we had it running on our own cases, and they said, oh no, we're going to send you a case and you do that. And you come and do it live. We'll give you the case just before we get on the Zoom call, and want to see you do it. So we did it. They sent us a terrible case. It didn't have any coverage. It was blurry as all get out. It was just an ugly case. And there's just no way they could ever analyze that case themselves. And we nailed it right there on the spot. So they said, okay, if you can do that, we're done. Let's go. So
they thought they were going to stump you, it sounds like, but
no, I think they wanted to make sure we were as good as we said we were. And we were, like I said, even in 2D, I mean, we've seen 3D image sets that you couldn't analyze. I mean, it's just a snowstorm, but you can't tell anything from anything. Yeah. But we've never seen a 2D ultrasound that we couldn't analyze. So we're pretty darn good at doing tough cases. And so I think that's going to be one of the things that GE will be promoting when it goes out to promote the technology, is that you can do things which you would normally think are totally unreadable. And yeah, you can read them. Yeah.
Were you, can you not talk about maybe the revenue model or specific financial milestones with the GE contract, or?
No, that's all confidential.
It's all confidential. Gotcha. That's okay. So talk
He's
about
pretty sensitive about that stuff. Actually,
I know.
When I worked for Pfizer, we weren't that uptight about it, but
yeah,
GE is. Yeah.
A lot of these bigger companies.
I guess devices are different than drugs. Yeah. For sure.
I guess so. Yeah. Talk about the importance of the relationship GE has with hospitals in terms of how much easier it's going to be for you to get your foot in the door and for people to see.
Yeah, it's the same with any sales relationship, especially when you're selling equipment or those kind of things. I mean, one of the barriers to entry for a small company is always the fact that there's a GE sales guy there who's had that account with let's say MD Anderson has had the account with MD Anderson for 15 years. And he just walks in past the receptionist, past the examination room, sits down in the doctor's office and says, how's the wife and kids and how's your dog? And,
yeah.
And so you walk in, you can't get past the receptionist, right? So yeah, it's always access. People like GE has, those salespeople have access, and they're frustrated right now because they haven't been able to do that for over a year because of COVID. And so they're really keen to get back out and go back and visit all their customers, and they want something new to talk about. And we've heard it from the head of sales saying, this is the new stuff in cardiac, and we haven't had a new thing in cardiac in 5 years. We can't, we haven't pushed 3D far enough ahead in recently to go back and talk about 3D. We talked about 3D incessantly for 5 years ago, and everybody's heard it, and it still doesn't work. So we're not talking about 3D anymore. We're talking about other things. And so you're one of those things. That's why we invited you into the program. So there, despite the fact that we had thought we would launch all of this 6 months ago, COVID has prevented the launch, an effective launch, and also there, it turned out that integrating into their platform was not a simple task. The fact that as far as I know, we're still the only ones who've got it to work. That analytics platform has been developed by GE over many decades, so there's a lot of legacy issues. It's not, there's a lot of legacy issues in that piece of software. So.
Yeah. And once I think, you talked about it's a new piece of equipment in the cardiac space for them to sell, but it's also, I think, relevant, based on what you mentioned earlier about the COVID long haulers and how there's going to be a need for, quick scanning, efficient scanning, and that's exactly what Ventripoint brings to the table, which is great.
Oh, I think that. And one of the things they never haven't been able to do, because even when you analyze 2D ultrasound, the cardiologist can't go back and say, well, what did that heart look? What do the numbers look like 3 months ago? Like what was the ejection fraction 3 months ago? What was the end diastolic volume 3 months ago? And they don't go back because there's so much variability. It's like plus or minus 25%. So
yeah.
There's no point in going back. So they're always just take the snapshot of your heart today and they go, that looks pretty bad, or no, that looks not so bad, or whatever, right? So with our system, because we have that precision, accuracy and precision, they can actually go back. And if they see a 3, 4, 5% change in ejection fraction, that's real. So that's going to change the way they do medicine significantly, because they're going to be able to actually look at the trend line of what's been going on with this patient's heart, and, with this therapy or with a different kind of thing, and change the therapy earlier when it's not working. And right now it's basically, I don't know, maybe it's working, maybe it's not. Come back in 3 more months. Let's go another 3 months and see what happens. Well, 3 months later, he comes back and says, well, therapy's still not working. Okay, now we'll change it. Well, poor patients had 3 months of, ineffective therapy, barely walk, because they don't have the precision in the diagnostics. Now they do. So I think it's going to change the way people get treated significantly.
Yeah, for sure. So obviously this is a big milestone for Ventripoint, and there's going to have to be a lot of training. Everything's going to have to get beefed up. Do you know what steps are you taking to do that, and what is kind of the timeline on when you need to have that ready to go, where you can successfully, integrate this GE?
Well, as I said, we already have 3 or 4 application specialists, sonographers that want to come work for us. Now we have money in the bank, we can hire them. So those are going to be trainers who not only train the salespeople to do the demos, but also train the application specialists, GE's application specialists. These guys are all echocardiographer guys. So it's not going to take them long to learn how to do the demo and get the sales pitch down. And the application specialists are going to be there to back them up if there's detailed medical questions that come back as to. So we're going to gear up. I think we'll have GE ready to go. We have to polish the software a little bit. It's totally functional now, but they want to change the look and feel a bit more, make it look more like a GE. Look at the interface and see exactly how they want to put it on the user interface and all that stuff. So there's a couple of months of polishing the software, and then those same 2 months we'll educate the sales force and the application specialists and refine the revenue model, the business model, and we'll be ready to go about when the US is coming out of the COVID haze and where most people are vaccinated at the level like UK is now. There's hardly any new cases in UK. So US will get there in 2 or 3 months, and that'll be the perfect, and GE will be ready to roll. And those salespeople are dying to get back on the road and to visit all their customers. So it's going to be good timing all the way around.
Yeah, I think the timing is great. And obviously, like in this industry, you know, once you have a company like GE adopt the technology, then you're probably looking at other companies who are saying, well, if they're doing it, we should be doing it too. Like
Yeah, I know they're all big companies. Big companies, you know, they all followed the bandwagon down the 3D bandwagon 15 years ago. You know, GE said, we're going to, you know, brought out the first 3D stuff, and everybody said, okay, GE's going that way. We all got to go that way. And, you know, Ventripoint looked at that and said, 3D is a long way off. It's still a long way off, in my opinion. So yeah, let's go a different way. Let's make 2D work. And 3D will be the analytical package for that too. And we're going to help GE. You know, we believe that we can overcome a number of the limitations in 3D, if not all of them. And we're going to do that work in collaboration with GE to show that we can turn 3D into a clinically useful tool, which is not right now. And that, you know, that'll be, you know, they've got warehouses full of 3D equipment that they can't sell because it doesn't actually work that well. But I think we can fix it so it does work. And so then they'll be able to sell all that equipment, and they'll make a lot of money doing that.
For sure. We have a couple other questions. Can you comment on 4D potential, please?
Yeah, so we've been working on, this is the 4D motion analysis that we announced that we filed a patent on a couple of weeks ago. So we've been working with a very elite group of cardiologists from around the world because we end up with a mathematical model of the heart that continuously through the heart cycle, all 4 chambers, we can measure all sorts of things that people were never been able to measure before. So we've been working with these group cardiologists saying, okay, what do you want? You know, strain rate, regional strain rates, you know, wall motion, you know, derivative wall motions, all that kind of stuff. So we now have a new suite, if you will, of cardiac measurements that's ready to go. And we want to, and we've got a couple of these lead cardiologists trying it out now on historical cases because it works perfectly fine on archived cases. And so we'll find out pretty shortly whether those new measures are giving the cardiologists much more detailed understanding of how the heart is functioning and how to treat it. So yeah, it's exciting times for us that's going to work. And that's what 4D is about. It's not only do we extract way more accurate and precise information about the heart from 2D and 3D, but now we're going to show them that there's even better ways to characterize how the heart functions.
Yeah, that's great. Can this AI program be sold and downloaded to a laptop, tablet, and/or flash drive? Or you have to use, obviously, the Ventripoint's equipment?
No, the software will run on a laptop. It's not that big a program. We actually have we actually have a version of the tracking system, which is USB. You just plug it into the USB port. So you can turn a laptop into a 2D ultrasound machine with a plug-in tracking system and a plug-in probe. So there's lots of, you know, and again, if you do, and that's what we're going to do with the vet application, because, you know, it's not that much, it's not that, you know, dogs' chests aren't that thick, and they're, you know, and so you don't need a $250,000, $300,000 ultrasound machine to look at a dog's heart. You can get by with, you know, $10,000 or $15,000 machine, or even a $50,000 machine that's been refurbished, and you can buy those anywhere for $10,000 or $15,000. So that's what the vets are going to use, and so we'll just be we're just going to supply them with the 2 things they plug in their computer, and they'll be able to go ahead and do the dogs. So
Yeah, that's
it's
amazing.
not computer intensive. We took the opportunity last year when we were back in 2020 to rewrite the source code completely from scratch. It hadn't been touched. It had just been added on for 10 years. So anybody who's a software engineer out there can imagine it's all sorts of different languages, and all the modules were all here, there, and everywhere. And it was just a terrible mess, piece of software, but it worked. So we took the opportunity to rewrite software. So when we wrote software, we made it the new version so it can go on a laptop, and we don't need these very expensive computer systems that we had on version 2 and the version 3. So actually the next generation of the VMS plus the human one for the human work will cost about half as much, about $2,500, because we're getting rid of we're going to be able to basically use an iPod computer to do it on. Yeah.
Great. So this is a question about the China partnership. I know you get one every single time we do one of these, but I know a lot of people don't know on this call, aren't familiar with what you have going on in China. So can you talk a little bit about that?
Yeah, well, we have a joint venture going in China. We've given a company, UTN Medical, the rights to manufacture and sell and in China, and we have an equity. We have an agreement where we'll get an equity position in that company when they get some decent sales. They spent 5 years building a factory and going through the Chinese regulatory process. They finally got approval in China for the device for version 1. That we're currently working on approval to get version 2 approved, and I guess someday they'll get version 3. So there are a couple versions behind us. But they are starting to get some traction. They've built a distribution network and a sales network across all China. They've got 8 machines out in the top hospital in 8 different provinces of China. And they're anticipating some significant sales later in the year. So we hope that all happens. We wish them luck. We will get a revenue, we'll get a piece of the profits because we'll have an equity position in the company. We also get a management fee, which is tied to gross sales. So it's essentially a royalty. So we get both an equity position and a royalty.
Great. Yeah, and that's another big piece of the puzzle. Do you anticipate?
Well, China's got 34,000 hospitals. They've got 1 billion people, and they have twice as much heart disease as we do. So the average admission in a North American hospital, about 13% of people have a cardiac problem. So when they get admitted to the hospital, it's 23% in China. So they have twice as many people. Every 4th person in China, in a hospital in China, is there because of their heart. So they do, they must do at least 5 times more scanning in China than we do in North America.
Yeah, that's going to be a huge market for you once that comes to fruition. Do you anticipate any sales of the current VMS 3 add-on system by GE, or will their focus be solely on upgrading their installed base? If GE's focus will be on their base customers, how will the current equipment sales be promoted? So do you understand?
So we're going to start, we have a rollout plan, but we've all agreed we're going to start in the United States. And we're going to start by upgrading their existing software to do 3D analysis. Okay, so the customer will be exposed to the technology and the ability to do accurate and precise calculations on 3D. And about 50% of 3D scans are good enough right now to be analyzed. So we'll start there and then you'll always need 2D. I mean, 3D will never get good enough to do more than 75, 80% of people. There'll always be 20 to 25% of people will not give you good enough images, even with our analytics, to give you an answer. So you're always going to have to fall back on the 2D system to get to be able to analyze 25% of the patients. So people will need both, and so we'll sell them both. Yeah,
that's great. And do you feel like you're capitalized right now well enough to be able to, handle any kind of demand, or do you think a raise is in the future? How do you feel about that?
Well, I think if, we have a bunch of things we'd like to do, and if the opportunity arises to expand the company and grow faster, and either, we may have to grow faster depending on how the adoption rate goes. We may have to gear up and take some money to go faster. But we would like to expand. I'd like to get going on doing things on regular old hypertension. As that last slide I didn't talk about on left heart applications. I think the biggest one I want to take a shot at is right now, when you measure hypertension in somebody, you get about 25-30% of people don't get properly diagnosed, and that causes tens of billions of dollars of downstream healthcare for people going to hospital with heart attacks, where they could have been all because they had high blood pressure for too long, and they could have been medicated with a 50-cent a day pill, and they wouldn't have had, so that's all hard data. That's all. So the problem is, how do we find these 30% of people who have hypertension and medicate them? And I'm absolutely convinced that measuring the volume of the left atrium is the way to do that. The literature is pretty clear that we should be able to differentiate from people who have silent hypertension as well as people who have white coat hypertension, and medicate them. So I think there's an opportunity here to put a machine in every GP's office and get rid of their sphygmometer, that nice machine they wrap around your arm and pump up and all that, and actually quickly and easily measure left atrial volume and use that as an indicator of when people should be medicated for hypertension.
Someone was just asking about the market for hypertension, and it's probably a huge market, especially in the States there.
2 years ago, they changed the definition of hypertension. When I was in grad school and in McMaster in the medical school, the normal was 120 over 80, and hypertension was 125 over 85. And about 2 years ago, they changed the definition to say hypertension is now 120 over 80. And again, that was because of this analysis that showed that if you actually medicate people and get them down below 120 over 80, you actually prevent a significant number of heart attacks and strokes and things. So the United States went from having 60 million people with hypertension to having 100 million people with hypertension overnight, because they changed the definition of hypertension. So scanning 100 million people every year, maybe twice a year, for hypertension is a huge market.
It really is. Well, I think we're right up against the hour, so I think we're going to leave it there. At this point, I want to thank George for coming on today and getting us up to speed on Ventripoint's lead product, and giving us an update on the new collaboration with GE. I think it's a game changer for the company. I haven't looked at the stock since we've been on the call today, but I have to say that I think, with the pullback, it presents an excellent opportunity for anyone looking to, get into the stock, and for those who already own it, to maybe take another look at taking a larger position. But it's definitely in a great spot right now. Do you have any parting words, George?
No, I absolutely agree with you. Obviously, I think, if you look at comparables for companies like us who've got, approvals in Europe, Canada, whatever, multi-billion-dollar opportunities, our 50, they would be 200-300 million market cap companies. So there's clearly a lot of upside here just to get up to other comparable companies. But beyond that, I think we have a lot of huge opportunities that would even make that small ones I showed you in CHD and pulmonary hypertension and cancer. That's only the tip of the iceberg. There's a lots more we can do with this technology to pull costs out of the healthcare system, and
absolutely
do a better job for patients, especially children. I mean, that's why I get out of bed in the morning. I think it's absolutely criminal to put children in MRI.
Yeah, absolutely. And most adults hate MRIs. I can't imagine what it's like for a child to be in there. So, and I happen to think that this, collaboration with GE is a precursor to maybe something bigger, maybe an acquisition down the road once they once you're embedded in their system. So we'll keep our fingers crossed for that. In the meantime, you can get any additional information on Ventripoint Diagnostics at the company's comprehensive website at www.ventripoint.com, including details on the VMS 3.0 system, as well as additional information in recent press releases. The code word today for everyone, just so you know, for feedback purposes, is Marlin, M-A-R-L-I-N, Marlin like the fish. We want to thank everyone for their time today to get up to speed on Ventripoint, and we look forward to your attendance at a future podcast presentation produced by Torrey Hills Capital. We're going to send out the feedback link right after this call, and I'll also send the BioPub video as well, and I'll tell you exactly where to watch from. I suggest everyone do it because it's a great insight into what Ventripoint is doing. Until then, everybody be safe, be well. Thanks, George. We will talk to you soon.
Okay, bye-bye.